go. All right, we should be live. Let me take a look at the stream and you can go ahead and get started and then I'll give you the thumbs up there. Can anyone hear us? Hello, internets.
Are we good?
Let's see. Usually we see people typing in.
All right. Well, I'm super excited to be here.
Yeah.
Haven't been back to this in a little bit. I think the last one I did was a couple months ago, but I think the super cool part about this is that the last time we were on a live stream together was a TGI Kates episode.
Do you remember which one it was? Because I do.
It was talking about Kubernetes 120, I think.
Yeah, it was a release. It was a release episode.
Man,
yeah.
That is so long ago.
Yeah, and now
I can't believe how much time has passed.
Here we are.
Both the VMware time. Crazy.
I know. And now you're at Microsoft. I'm at the CNCF. And what are we talking about today?
Today we're going to dive into the Kyverno a little bit more. I think last time I was here, we were doing Kyverno. Kind of walked through the basics, got it set up, and explored some sample policies a little bit. One of the things I noticed when I was digging through stuff was that there was support for image verification. So doing things like, maybe I want to verify signatures for an image, or I want to make sure that it's got some sort of attestations for supply chain security reasons applied to it. So I really want to dig into that. My day job right now at Microsoft focuses a lot on some of that. So this is super relevant and interesting to me. And I hope it's all, going to be useful for other folks as well. I think we're kind of in this world now where there's so many different things in that space, and figuring out how we can better roll that into our policy enforcement just seems like a totally natural thing to dig into. So that's kind of where I was going. I think last time I was also maybe gonna scratch the itch of trying to write a policy from scratch, because I think last time we just used some sample ones and see how that goes. Do the old live coding thing. And then I also noticed as a comment on the last video, I went to check it out on YouTube just to refresh myself. I saw that Jim from Kyverno answered a question that I had about policy reports. When I was kind of walking through stuff, I wasn't sure whether you got policy reports for things that were blocked. Kyverno allows you to run in like audit mode or enforce mode. So, your policy may, if it fails validation, if it's a validating policy, you can just log that and audit it, right? And that'll show up in those policy reports. But if it's something that is rejected, there won't be anything to really record in terms of a policy report, but it will get emitted as an event or in the metrics. So I think maybe we'll dig into that just to see what that looks like a little bit too.
Ooh, okay. That'll be great. All right. Well, go ahead and share your screen. I'll fade into the background. Chat, if you're listening in, feel free to post questions in chat, and we'll just go ahead and go. We like to keep it nice and loose here, and hopefully see Jeremy. I can't wait to see you break stuff. I enjoy watching you break stuff.
It's always fun. All right, is my screen coming through now? Looks
it good. Is. Let me figure out how to. Oh no, that's not good.
The layouts are always fun.
I think what I want to do is this.
Can you make me smaller? Boom! There we go. That looks perfect. Okay. Before we jump into Kyverno, though, I thought this would be a really fun thing to share. Dapper is turning 5. So kind of on that topic of, I can't believe, we were on that TGI Kates episode for 120. That was a long time ago, like in 2020. Dapper is turning 5, and that just blows my mind. It feels like it's a super, super new project, and it's been around for 5 years now. So Dapper Day, there's a CFP open until August 5th. If you are doing anything with Dapper, totally submit something to this. I think having the opportunity to go to the Kubernetes Turns 5 party, KubeCon, many years ago at this point, it's really cool to be sort of part of those milestone events. And, this is a really cool one that I would recommend everybody else. If you're into Dapper, check out. And if you're not into Dapper yet, this is a good opportunity to learn more about it too. But 5 years, that's really, really cool. All right, so let's jump back into Kyverno. If anybody can correct my pronunciation of it in the chat, that would be great. I don't know if it's Kyverno or Kyverno, but I'm gonna go with Kyverno. It sounds better to me. Okay, we're going to use version 1.12. So as we're going through this documentation, we're going to pick back up kind of from where we were before, but not really. I have a brand new cluster that's here. I just set up a Kind cluster, and I just used Helm to install Kyverno. I think last time I maybe used a YAML file to do that. I have the YAML file still, but we're going to use Helm. That seems like a good way to go. So I've got the project running. Let's just verify that though. Let's check all the pods that I've got installed. So I've got all of the Kyverno pieces running, looking like they're good. So I think we're ready to kind of get started. Like I mentioned at the start of this, really interested in the image verification stuff. I do a bunch of supply chain security related things at Microsoft. My job is to help build and publish a lot of the CNCF projects that we're going to use inside of Azure. And as part of that, we do things like sign containers and generate SBOMs and salsa metadata, like all the cool buzzwordy things that are really useful for us to help reckon and enforce that we're using proper things. So let's jump back to the docs for a second and kind of go from there. So again, a lot of things that you can see inside of here. The policies section here, kind of what we went through before. Lots of really good stuff inside of here. And actually, some of the image policy things are in here, and we can come back and reference them in just a second. Of the things that you can use policies for, there's a bunch of different objects that you can write policies against. I think what we're going to look at is pods, deployments, things that are going to use pods in the end. And because we're kind of looking at image verification related topics, that seems like it's going to be the most useful place for us to kind of dive into. But I remember from looking at the docs last time, under writing policies, there's a whole section on writing policies around verifying image rules. So we're going to dive into that and kind of take a look at things that are here. This is a beta feature, so living dangerously, not using something that's GA'd yet, but I think it's been around for a couple of releases, so hopefully it's not too terribly dangerous to use at this point. But always beware of the risk that kind of comes along with some of that stuff. You've got your nice big warning message there, but let's jump into it a little bit. Okay, so we're going to do things around checking container image signatures and attestations for supply chain security, just like I mentioned. And I think from the documentation that I see here, there are two main sets of tooling that are available to do this kind of enforcement and this kind of verification. One of them is SigStore. That one is going to include things like cosign for doing your signature verification, probably also the other components of that ecosystem. There's a component called Recore and another component that will generate certificates that are short-lived. So it's this really cool integrated ecosystem that allows you to do this really fun kind of easy to use, especially if you're using something like GitHub Actions workflow, where you basically have these keyless signatures where you don't have to have long-lived certificates that you're managing. It's really tied to the OIDC identity of your GitHub Action workflow. So you can do really cool things about asserting that it came from this pipeline or this GitHub Action from this repo and have a lot of assurances about what you're doing. The other one that's here is Notary. And Notary is another long-running project. There's actually like a second version of that, and I think that's what this is using, and they kind of call it notation now. That's like at least the CLI piece of that, and I think we're going to use that. Just another CNCF project. The SigStore stuff is totally cool. If we have a little bit of time, maybe we can jump into that too, because it's also pretty easy to get going. But we're gonna go with CNCF flavored things today. So just before we dive into that, the notation tool that's part of this is part of the Notary project. If you go to github.com/Notary project notation, you'll find all the stuff in here about how to use it, and stuff for their community calls and quick start guides, all kinds of great things there. This one is a little different. This one does really require you to manage your certificates and keys that you're going to use for this. And it does that through extensions or plugins for the tool. It doesn't have a lot of that baked into it. It does have like a test certificate baked into it capability. So we're going to use that as we go through some of this stuff. But Key Vault and in Azure and AWS Signer, and I think there's a few others, are available as plugins that you can use within that. So it kind of integrates with your cloud ecosystem. Okay, so back to the Kyverno docs. So it looks like we can do both cosign and Notary. We can do things like verify digest. That seems pretty cool. We can mutate digest. I think that's probably converting tags to digest for your images, which is a really great way to ensure that you're deploying the same thing all the time. If you are using tags, those are mutable, of course. So you can get into situations where you've deployed, and maybe if you're scaling up or scaling down and you're only using the tags, it's possible you might end up with a slightly different version of something. Using the digest is a great way to really kind of have that immutability for your images and make sure that you're going to deploy the same thing all the time. Looks like we can provide credentials and all kinds of good stuff there. So verify image rules can also contain a list of attesters or authorities used to check the attached image signature. So it's going to be based off of the tool used to sign the image. So SigStore supports public key certificates and that keyless approach. Notation isn't going to have that. It's going to rely on the certificates that you're going to manage. We'll jump into that one in just a second. Looks like they can also contain a list of annotations, i.e. signed metadata to check for the image. Probably a few different things are available there. We'll see what we can get through. Yeah, image credentials, if we're going to pull from a private registry, that makes a lot of sense. All right, I'm just going to dive into the notary section now just to get a little bit more context on that because it's a tool we're going to use. Okay, so Notary is a CNCF project that provides a specification and tooling for securing supply chains. The notation CLI, so right there, that we jumped to just a second ago, is what you're going to use to do the signatures inside of your CI/CD pipeline. GitHub Actions available for that. Pretty good quick start guide linked here, I think. But it looks like they've already provided one for us. So using the notation tool, it looks like you can use inspect to look at this image that was produced. So this is going to be their image that the Kyverno folks have built and maintained. It looks like they've signed it with Notary or with notation. So let's give that a shot real quick. So we're just going to grab this, and you notice it's using the digest again. Tags are mutable. Pretty good practice to refer to the digests. And I think that when you're using notation, it'll resolve things to digest and really kind of work in that pattern. Okay, so here's our cluster. It's running fine. I have notation installed already. Cool. Okay, so let's run notation inspect for this image. All right, looks like we got back stuff. Let's see if anything's changed. So this was signed on Monday, May 22nd. Yeah, looks like it was May 22nd, 2023, and it expires in 2033. So we've got a 10-year period to use this image. Hopefully there's a new one by the time 2033 rolls around, and the Kyverno docs aren't pointing to this one, but that could be a fun one. So we see here that there is a notary signature, and this is the digest of that signature. I think the way that notation works for this, it's using OCI artifacts and a couple different ways of associating things back. We'll look at that one in just a second too, because I think that's going to kind of come into play here. Yeah, so there's the signed artifact, and we're looking at the image B31BF B4. Okay, so that's what we see here. This is kind of exploding out all of the notation information for us. We see what was signed, and in this case, we've got the digest of the image that we're using there. So that's cool. Okay, you can also use an OCI registry client to discover these signatures and attestations. So they're going to use something called ORAS here, and ORAS is another CNCF project, and this one is a good description in here. It doesn't look like there's a really good description. Documentation for the ORAS CLI is on the project website, orasland.cli. So let's go over to that. So what is ORAS? Let me make that text a little bit bigger, probably a little hard to read. Okay, so registries are evolving as generic artifact stores. To enable this goal, the ORAS project provides a way to push and pull OCI artifacts to and from registries. Okay, so what is happening here? Let's go back to that image again. Okay, and let's use ORAS. I think what they did here was discover and then they're outputting a tree. Okay, so let's do that. Oh, they're using the tag. So let's compare them and see if there's a difference between these two. Okay, so we're gonna just copy and paste this command first, and then we'll jump back and use that specific one. Hello from India. Nice to see you on the stream. Oh wow, there's a lot of stuff inside of here. Let's pipe that into more so we get a little bit easier to digest content on this. Okay, so there's our image. Looks like it's the same one, B31BF-B4. And we see there's a notary signature. Actually, looks like there's two of them. A vulnerability scan, a Cyclone DX SBOM, a Cyclone DX VEX document, so a vulnerability exchange document, a Trivy scan, and some Trivy vulnerability information. So it seems like there's a lot of stuff attached to this, hopefully that we can use as part of that image verification workflow. So let's go back to the docs and see what's next in our agenda here. Okay, so we've got the image. We know it's there. We know that it's been signed, and there's quite a few more things attached to it at this point than what's in this sample documentation, but there's a lot of stuff. Okay, so it looks like the following policy checks whether an image is signed with a valid X509 key that matches the provided certificate. So in this case, we've got that verify images rule inside of here. So we saw that kind of at the top level here. And inside of that, looks like we are going to apply that to pods. That makes sense. And we're going to use type notary. So that kind of corresponds to the docs we saw just a second ago. Image references looks like we can be pretty specific or generic with wildcards for as far as we want to go. In this case, I think because this is notation, it's going to the attesters that we saw in the other bit. Certificate's going to be the only thing that's really valid here. If we jump to SigStore real quick, we look at that doc. Looks like you can use public keys for that one and verify that against Recore. Looks like you can do certificates as well somewhere in here. Certificate-based signing and verification. Yeah, there we go. So kind of similar. This one is using the type isn't there, so maybe it just defaults to cosign. That would make sense. But similar body here, right? We've got an attester and certificate, and then the cert that goes along with that. Okay, so let's give this a whirl. So what we're going to do is take this policy, copy it, and I'm going to drop it into a YAML file here, just so we have it locally. I'm actually going to bring up Visual Studio Code too, so we can take a look at it in a little bit more depth than the browser window's giving us. Okay, so let's look at image verification policy. So this is it. It's going to be named check image notary. The type there is notary. I think this one, if we left it off, would default to cosign. So we can check that in a second. And then this is where we're going to specify our image references. I think if we pull from another place, it won't apply to that. So we'll give that a shot too and see how that goes. But there's a certificate that's embedded inside of this thing. So if we go back to our cluster and we do something like kubectl, actually, did this have a namespace? Nope, it's going to be in the default. Oh, it's a cluster policy. Okay, so it'll be not namespaced probably. So let's do kubectl apply -f image verification.yaml. Okay, so we've got a cluster policy kyverno.io/check image notary that was created. So let's get our cluster policies. All right, and we see the validate action is enforced. So this should be blocking everything for us. If we try to run something from this repo, Kyverno test verify image that's not signed, it should be blocked. So we're going to verify that and test it out. Okay, so let's do that. Let's see if they provide us the docs for that too. Yep, right here. Okay, so we're going to do kubectl run here with our image, GitHub container registry.io/Kyverno/ test verify image with the signed tag. So let's run that and see what happens. Okay, our test pod was created. Let's take a look. Oh, actually, it dry run that thing, so it did not create it. So let's drop this off and see what happens. Okay, test pod was created. Okay, so it's running. Perfect. So that was our signed image. Let's see if we got any events in here that kind of correspond to that. Kind of curious where we would see the enforcement information. Okay, so let's just take a look at the emission controller logs and see if that has. Okay, yeah, here we go. So here's our engine verifying stuff. And verifying image signature, verifying image. There's the content that came up. Verified image. So it should be good to go. And if we now take a look at this thing, did it do anything else? I don't think it resolved our digest for us. So we can maybe add that to this in a second. I think that might be kind of cool to see. But if we do kubectl get pods, there's our test one, and we do kubectl describe pod test. It did rewrite that to be the digest along with that. So we've got a reference there with our SHA and everything, so kind of good to go there. Okay, so we got that, and it allowed that image to come into the cluster. Let's take a look at what happens if we don't. Yep, okay, so Kyverno will also mutate the pod to replace the image tag with this digest. I think we could probably turn that off. We can experiment with that too. But this is where we should get into the fun stuff. So let's go back. And here we go. We're going to run with the unsigned image this time and see what happens. All right, so just like we expected, the emission webhook blocked that thing because this image was not signed with the key that goes along with our policy. If we do something like for us discover on this thing, we see there's nothing attached to it, right? So this could be signed with a different key, and we would probably get the same kind of error from that. And maybe we can check that in a second by copying this to another registry. Let's actually do that. So we're going to take this GitHub container registry instance, and we're going to copy it to my ACR instance. So I've got, let's log into it. I made this so long ago. It's been running for a while. I've got an ACR instance called KubeCon EU, and I was amazed that was available as a name in ACR, but it's there, so that's cool. So we've logged into that thing. So now I should be able to take this image and put it into my own registry. So let's do that. And to do that, we're just use ORAS again. So ORAS has this cool copy command. Yeah, so it's going to copy things, right? You can copy images, you can copy OCI layouts, you can do all kinds of really cool stuff with it. But by default, the easiest thing to do here is we're just going to copy it. So our image was named that. So we do an ORAS CP this, and then we're going to put it in KubeCon EU.acr or Azure CR.io, and we'll put it into the same place. Kyverno test verify image unsigned. Okay, so now I've got that image. If I run ORAS discover on it again, perfect. Nothing's there, right? It's unsigned. So if I were to run this command again, I bet, and I use my reference here, I think this should work, right? Because the policy there, that's why the dry run. Let's kubectl delete pod test. Just to make it easier on ourselves. Okay, so there it did not block it, right? Because in this policy, I am specifically referencing my my image there. So now let's try this. Let's delete that pod again. Okay, so that's deleted. If I come back over here and I add another reference here, will that do kind of what I'm looking for? So we'll go back to this and we'll change this to kubecon EU dot AzureCR.io. Okay. So we've got that. It's terminated still. Okay, so let's just reapply this policy. Okay, so it's been changed. And we should see, yep, our second one there. Okay, cool. So let's, okay, so the pod is gone. So now, moment of truth. We're going to run this again, and I'm pretty sure this will fail. Looks like it's, yeah, so it's verifying it, right? Because it hit that. And in this case, it's not signed. Okay, so what if we signed it ourselves? I wonder if we could make a second policy for this with just that signature. So let's do notation. I don't know how to do this. Notation key. Okay. So there's a generate test command. We can do that. So let's do notation certificate generate test, and we'll call it CLBO. Okay, so now we've got that CLBO certificate, and that has been written out to here, right? So if we weird. Oh, there's a space. How fun. Okay, cool. So there's our certificate, right? Let's grab that. Actually, let's make another policy here. So we're gonna first image verification.yaml, ACR image verification.yaml. Okay, so now we've got two files, right? So let's go back to here. Let's remove this policy. Let's apply it again real quick. Oh, sorry, forgive my bad keyboarding. Okay, so that's configured again. And if we run this command, should be fine, right? Yep, it's created. Okay, so let's delete again. Kubectl delete pod test. Okay, so we're going to take this certificate, which is the test one that we just created. Probably won't be valid for very long. And we're going to put that into our other image. Is my VS Code not popping up? I feel like I see the sample window there. And
that is my bad. I still have you on the docs. Sorry.
That's weird. I shared the whole window, didn't I? Let me share it.
Can you like reshare it? Thanks to who? Someone just pinged me on Slack. Thank you for that.
Man, I'm sorry. Let's go back and we'll hit that again.
Yeah,
screen
quick
sharing
summary.
is not allowed. So let me share the window, I guess. And we'll have to kind of jump back and
There we
forth
go.
between a couple things. I'm sorry.
Sorry about that. Thanks for the call out. Yeah.
Yeah, I just looked at the screen share and it wasn't showing anything.
Okay, hold on. Yeah, let me get the layout right. Thanks.
Okay, cool. Yeah, so let's try that out again, just to verify things. So we're gonna do. It's showing my VS Code window, right? Okay, so you know what I could do inside of here? I think this might be okay. Let's get a terminal. And let's get rid of that. And this isn't very efficient. So I may have to stop sharing and share again, but we'll do that in a second. Okay, so just to recap, what we've got here is this check image notary policy, and inside of it, it's an image reference to GitHub-Container-Registry.io/Kyverno test verify image, and there's the certificate that goes along with that thing. So let's bring our terminal window up real quick and make it full screen. Okay, so in here we've got our no pods created, right? So we're gonna do kubectl apply. Ooh, nope. Test. Okay, here we go. This is the one I want to show what we're going to do here. Okay, so we've got signed and unsigned, right? And just to catch everybody up, because we didn't have the screen share before, with notation or with ORAS, and we're going to use ORAS for this one. Here we go. We're going to look at this image first just to see what's on it, right? So we get rid of that kubectl command. So the ORAS command has this discover subcommand, and we can see there's a whole bunch of stuff that's here. But the thing that's really interesting is this notation signature, and that's what we're going to use for verification of stuff right now. And we'll do notation verify of this image as well, and it'll give us some more detailed information about the signing piece. Okay, so it's using the tag there. Oh, I did verify. That's not what I want. I want to do inspect. So there we go. It's trying to verify it with my trust policy locally, which is not that key. Okay, so here's the inspect command that I ran earlier that nobody could see. So here's where it's showing us the signature and all of the good stuff that kind of comes along with that, right? So this one is signed. The other one that we're going to use is this unsigned, and this one doesn't have anything, right? So we can run the same ORAS command, and we'll use unsigned there as well. Cool. So this one doesn't have anything attached to it. So there's the signed image that's got all that stuff, the unsigned image, which doesn't have any of the fun things along with it. Okay, so let's grab that command again. We're going to run this one right here. Which is this command. Okay, so I'm going to clear this out. And again, our policy, let's make sure it's applied. Okay, so image verification is there. And again, if we go back to the image verification, this is going to match against anything in GitHub Container Registry.io/Kyverno test verify image. So it's pretty specific, right? We can be really detailed about the things we want to grab from there. Okay, so now we're going to run that. Here's our test. We're going to run the unsigned one first. And we see that this was blocked from the policy because this wasn't verifiable, right? When we try to do the inspect of it, there was nothing there. So there's no signature. So what this is saying is that policy requires us to have the signature attached to that image in order for it to go through. So if I do the same thing now, but I use the signed image, the pod's created and everything's great. Let's delete the pod and just kind of run through that again real quick. We'll catch up. Okay, that pod's deleted, right? So if I do the same test here, but I use my Azure CR, my ACR instance, which is KubeCountyU, Same image. I just used ORAS copy for that, and it looks a lot like this. ORAS CP, and then source and destination, right? And this should be a no-op now because it's already done. Yep, it's a no-op. So now if we run this run command again, but we're going to use my GitHub, or sorry, my Azure CR instance, the policy doesn't apply to that, right? Because this doesn't match AzureCR.io. But let's make a second policy. So we've got that one in here and over here. We created this ACR image verification, right? So we're going to change the name here, ACR check image notary. And instead of this GHCR, we're going to use KubeCon eu.azurecr.io, right? So let's apply this one. Get rid of the pod. I totally understand why the docs have the dry run stuff in it, because then you would not have to be deleting every time like I am. Okay, so let's kubectl apply -f the other policy. So here's our ACR image verification.yaml. So we've got two now. We should. Let's we get cluster policy on these. Did I type correctly? Okay, so we've got two. They're both set to enforce. So now if I run this test again with kubecon eu.azurecr.io, we should be good to go, right? This should fail because it's going to match that second policy. It looks like it's taken a long time. And yeah, there we go. So it failed just like the one in the other repo because we changed the thing to verify that. So now let's sign it. So we can do notation and see there is a sign command. So we're going to do notation certificate list. So I have a bunch, right? So here's my CLBO one that we just created. And let's do notation sign, see what we need to do. So we need to use the key that we want to use and the registry reference that we want it to basically to use. The default signing key is this way. So let's try that. Let's just see how it works. So there's our image, right? Okay. We're going to do notation sign. See if it works. I might have to provide the key. Probably will because I've got multiples. Yeah, it's trying to use a different default one. So let's do notation key list. See which ones we've got. We've got our CLBO key. Okay, so let's try that. Let's do notation sign. Do I have to use the full path? Totally possible. Oh, actually, it's just called CLBO, right? Ah, okay, cool. Yeah, it's just called CLBO. The kind of formatting there was a little off for me. Okay, so now that's our image. And if we come here, and we ORAS discover that thing, nice. Include all of the letters, not just part of it. Now we see there is a signature attached to it, so we're good to go, right? Let's find out. So we're going to do the same run command, right? Which is here. Ooh, that still failed because the certificate's wrong, right? It's signed with a different certificate than what is in that policy. So what we want to do here is let's get the cert itself, which is this. Okay, so back to our policy, which is here. We're going to drop this in, and we're going to align everything so that it looks correct, and then we'll delete the old one. Oops. Almost there. Yeah, I can't remember the key tab or the key code to do the block. I never remember it. I never use it often enough. And I go back and forth between my Windows and my Mac machine, so I don't want to like struggle with it. So we're just taking a little bit longer here. Sorry. Okay, so there's our certificate, and we should be able to remove this one. Boop. Okay, so now let's go ahead and recreate this policy. Okay, back to our terminal. Oops. Okay, back to our terminal. We're going to do kubectl apply -f ACR. Okay, so it was reconfigured now. So this is the moment of truth. Can we run this thing now? Yes. So we made that new policy with the new certificate inside of it, and we're able to run things. And I think this is really cool because this shows us that we can do multiple different policies, right? So we can have our ACR check policy, which applies only to my Azure CR.io. We can have our regular image verification one here that applies to GHCR.io. So if we're consuming images from multiple places and those things are being signed by different folks, maybe within our org, or we're a fancy enterprise and we're running things in multiple different repos, or different teams are responsible for all those things, and they're signed by different keys. We can make different policies to handle all of that for us, which is pretty cool. We can get really, really powerful with that. I think like a next step that would be really cool to see here is to actually restrict registries to only allow things to come from GHCR.io or from my KubeCon EU repo. So let's try that as our policy writing thing. So I'm going to delete this kubectl test. And then I think, because I can't share my whole screen, I'm going to have to stop sharing this one and jump back into the docs for a second. So let me do that. Okay, I'm going to share window again. Boom. Okay, so we are back to screen sharing. Perfect. Okay, so what we want to do now is, we can take a look at some of the other things that are in here. I think is kind of useful. So we noticed when we did the discovery on this thing that there were signatures. That's what we just validated. Also, a vulnerability scan report from Trivy, I think, that was signed using Notary. So that's really cool. You could verify that it's maybe got a. In this case, it's making sure that there's a SBOM attached. So maybe you've got a policy that you want to have everything in your cluster have an SBOM attached because it makes it easier for you to discover what vulnerabilities are there or what dependencies you're managing. My image has XZ inside of it, and there's a problem. It's got SSH inside of it for reasons, right? The SBOM might help you discover some of that. And what this is saying is that it's asserting that there is an SBOM attached. It is signed by that. And here I think they're checking for licenses. So they're just checking to make sure that everything is GPL3. So you want to require, maybe you don't want to use GPL. You want to have a block for that, right? So you could do the same sort of attestation in addition to the certificate validation that we did in that example. Lots of power that you could do in some of this. I think in the SigStore example, they're also looking at things like offline registries. They're doing things like the keyless signing, using private registries. Annotations are a cool one that SigStore supports. But in the couple minutes we've got left, let's try and make ourselves a policy that's going to restrict the images and require the signature. So we're going to do both. Let's go put that together. So let me stop sharing again, and we'll jump back to VS Code so we can do that. And boop. Okay. All right, so we are back to sharing. Okay, so we've got our policy in here today, which is our ACR check policy, it's cluster policy. It's got a few different rules inside of it. Verified notation signature, notary, doing some of those things. Let's make another policy. We could probably put all of this inside of one, but I don't know. I kind of like making individual policies myself. So let's do restrict images.yaml. Okay. And then what we're going to do is grab a little bit of metadata here. And let's name this restrict image policy. Okay, so what things do we need to match on inside of this? So we want a spec that was in the docs. And I think in this case, we want to validate and not enforce. We can change that though, so maybe that'll be cool. All right, so we're going to do rules, and I'm going to call this validate registries, and then match. Okay, I've got the docs open on this other screen since I can't hop back and forth. But what we want to do is, I think any is the keyword we want to use here, and then the resources that we want are kind pods. So we're going to match this against anything that comes in that is a pod, right? That's going to give us our I think I missed yeah. So it's going to match anything that's a pod. Cool. And then we're going to validate. That's what we're going to do. Instead of mutating, like we could mutate things and maybe say like everything that's coming in that's not in our official registry, like we want to change it so that it's from our ACR instance instead. That's probably a good policy to maintain if you have a good image mirroring policy, but maybe you're mirroring all of your open source dependencies into an internal registry. So you can do things like sign them like we just did. Maybe you want to have that as a mutation policy to really enforce it. Okay, so we're going to match a pattern here. And I think yeah, okay. What we want to do is this is the spec we're matching inside of the pod that's coming in. So a pod spec has containers, right? And it's got an image tag or image field. So we want to say that everything has to be in KubeCon eu.azure.cr.io, and we're going to wildcard that. We could probably get more specific if we really, really wanted to, but in this case, I think we're just going to go with this, right? So this will allow us to run this policy and then try to create the image with the GitHub Container Registry reference that's signed. So that should go through this policy, the image verification one, but this one should audit it for us and tell us that it's not good. So let's apply it and see what we get. Where's my terminal? There it is. Okay, so kubectl apply. Let's go back over here so I can see the chat and stuff if anybody's asking anything. This is called restrict images.yaml. Oh, okay. So validation failure actions in force audit are deprecated. Use enforce/audit instead. Deprecated. So maybe my docs are a little out of date, but here we go. So we've got this this thing created, our new restrict image policy, and let's don't have any of our pods, so we're going to run okay. So there's our signed image. This should go through the validation and hit that policy, but hopefully our auditing one will catch this. So let's give it a check and see what happens. Okay, so that went through because restrict images was not. Okay, so we've got our audit policy here. Let's check it out. Ooh, boy, I can't type today. Policy. Okay, so we've got a rule count here where it validated one. I think that's, oh, actually, that's just the rule count. It's doing a validate. Any events in here? Ah, cool. There we go. So we see that there was a policy validation here because the validation failed on pod tests because it wasn't in that registry, right? So now let's delete it again. And let's edit our rule here. So I think you're able to do like Boolean kind of like logic here. So I can say like or instead. And let's put in gc GitHub container registry.io Kyverno star. And I think we got to put quotes around this probably. Why is that erroring for me? Oh, because it's got to be like that. We don't want quotes around the whole thing. It's for the full expression, right? So we're going to match against this or against this. I think that's the right way to go. Okay, so let's apply that again as the clock winds down. Okay, so actually, let's fix this too. Don't like warnings. So I think what it's saying is that this should actually be audit instead. So let's go back and apply it one more time. Ah, there we go. No warning. We've got a clean screen. That's great. Okay, so let us try and... Okay, our pod's not there. So let's do our run again. Oops. Okay, so we're going to run that test again with ghcr.io, Kyverno test, verify image side. Okay, so that went through. Do we have a brand new? Sweet. We don't have our validation error. Ooh, actually, do we? Policy validation. Rule validate registries failed at spec containers. Okay, so let's. Seems like I maybe have an error in this policy. Let's give it a shot here. So we're going to change this to enforce. Okay, so we've got spec containers. And oh, you know what? I think this is probably invalid because that's an array of things in the YAML. That's probably going to be my problem, right? Okay, so now we've done that. Let's we've deleted that thing. Let's apply it again real quick. All right, moment of truth. We're gonna run this again. Okay, so it allowed it in, and the policy is set to enforce right now. And here, yes. So this is our old one, and here is our new one, right? So this it went through and it was fine. So again, just as a last minute thing, let's delete it. Let's edit the policy one more time. Let's drop off that GHCR thing again. So we just got our KubeCon EU Azure CR.io registry in here, right? So back one last time. Cool. And run it again. There we go. So it was blocked this time. We ended up with a validation error there because it didn't match, and that's really cool. I think if I was to go back and change this to audit, and we ran that again. Okay, so it went through, and I think we'll get an event this time. Yeah, there's our validation failure. So it failed to validate the image with that registry. So that's really cool. I think maybe would be a little nicer if when I had this error, like that's not valid, but it's pretty hard, I think, to validate that these are going to match things correctly against lots of different types of YAML. So something to be aware of. I think as you're writing those things, make sure you've got your pattern down correctly. But yeah, I think so. I think this shows a couple cool things, right? As an enterprise that's going to run stuff, it's a really good practice to not depend on registries you don't control, right? The move from kates.gcr.io to registry.kates.io, perfect example of impact when things out of your control happen, right? Like, so kates.gcr.io stopped getting new things, and if you're trying to pull from there and it's no longer there, you've got a little bit of a problem, especially at deployment time. And if that registry ever went away and you're pulling from there, you're going to have a bad time, right? So good pattern is to kind of mirror a lot of those things into your own environment. And I think one of those policies that we just saw, like the ability to enforce that the containers are coming from a specific registry, it's a really good kind of practice to maintain, right? Like, we want to validate that we are. You probably also could like negate this and make sure it's not coming from a specific place. But a good pattern would be to like enforce that we're going to pull things from the registry that our team controls and manages, right? We're going to only use the things that our company has control over. And then we can layer that with additional policies to say, we want to actually, in addition to only allowing things from this registry, we also want to ensure that it's been signed by a certificate that we know. We also maybe want to see that it's got vulnerability scans attached to it, because we've got a couple of different processes in our software development lifecycle. We scan all of our images on a regular basis and attach those things so that they're available. Same for SBOMs, right? Whatever you're kind of looking at in terms of the whatever you're looking at in terms of policy, it seems like you can do a lot with Kyverno for this. And I think with that, we're gonna wrap it up.
Yeah,
I seem to have lost the window here. I see it still, but there's nothing in the tab, so I can't see if
can you hear me?
are any. Let's see if I can bring it back up to this screen. Boop.
Jeremy, can you hear me?
That's super weird. George, can you still hear me?
Yeah, can you hear me? Can you hear me? I don't think so.
Oh man, did I lose everything?
You're okay. What if I hit that? Does that work?
Huh. Well, if you're still hearing me, sorry. If you are okay, cool. Yeah. I just pinged George offline, so I can't hear anything. It was really awesome to be back and doing this again. I think Kyverno is a really, really interesting project. A lot of potential inside of it. I think we still, with 2 episodes, have just kind of scratched the surface of what's there. I'm going to keep looking into it. Feel free to ping me on Twitter, on CNCF Slack, if you want to chat about any of this. If you have any ideas about other really cool things inside of Kyverno to look at, would love to hear from everybody. But it's been great being back, and hopefully I'll see you again. And if not, then have a